All right, so let's talk about 12 valves. I was going through the 12 valve builders forum last night a little bit and saw a couple that stood out and kind of wanted to discuss them. So you read it a lot. And often people are getting a new truck or new to them, but it's 25 years old at this point, and they're wanting to know what to do really quick, really easy, that's effective. And really, there's a bunch of different half-assed ways to do things incorrectly, and there's a bunch of different ways to do things pretty correctly. And as much as I've tried all of them, I feel like one of the most important things that a person can do is keep the injection event as violent, hostile, short, and effective as possible. So by pulling out the fuel plate,
Yep.
that's the opposite of violent. It's a lot of fuel, but you're just running a ton of duration through the injector, and that's not great. And then the next thing that you always read is, how much timing should I have? And basically, diesel is a slow burning oil compared to gasoline. So depending on how much diesel is going in the hole, you have to give it more and more and more advance. And again, if you're going to open up the injector on time, then you need to advance it even more. If you're going to keep the event really short and tight, then you might want to give it a little bit more, because you are getting more fluid in the hole and it takes a little bit more time, but you don't got to get carried away with timing. And on a 12 valve P-pump style truck, the more timing you give it, the noisier and the louder the injection pump gets. It gets real knocky, and they don't start that great. They make a lot more cylinder pressure because you're injecting fluid before top dead center. So as the piston's coming up, you're starting to already inject that fluid. And if you're at 16 degrees before top dead center, you're not making a lot of cylinder pressure. But if you're at 18, 19, 20, 27 degrees, well, think about it. That piston is a way, way, way down the hole as you're starting to make cylinder pressure. So they get real noisy and they want to fight themselves, and you're constantly making a bunch more cylinder pressure that you don't really need. So I don't love doing that, especially on street trucks.
Yep.
You read the post about the head gasket thickness.
Yeah.
And one of the first comments was, you might as well O-ring it as well. So I bought the, is it BHJ or BJH tool?
Yeah, something like that.
A long time ago, and warranties of head gaskets went way up, so I sold it. And then 5 years ago, I bought another one because I learned how to use it, basically. What's your thoughts? Why would anybody choose, if you've got a standard 058 thickness head gasket and you're doing a head gasket, why would you choose to go 10 or 20 thou thicker, you think?
I mean, the only reason that I would even know is if a guy like decked the block a ton, that's basically your reason.
That's it. If you've had a leaky head gasket for a long time and the block surface, you can go 2 thou side to side, 3 thou front to rear in variants, and the composite style gasket will kind of conform to that, and it will work. Now bear in mind, that's factory spec with factory horsepower. If you're making triple or quadruple the horsepower, then you better tighten up your spec even tighter than that. So if you go to pull the cylinder head off and the top of the block, number one, what don't we use to clean up blocks or heads?
Oh, the flappy wheels?
No pneumatic tools, ever. Don't ever use a pneumatic tool when cleaning off a head gasket, because we have a tool and it measures surface finish and it measures like the high and the lows. And 2/1000 isn't very much, guys. It's thinner than your hair.
Very thin.
So if you're out there with a 3M roll lock wheel going, making it all polished and clean, first off, the really smooth surface finish isn't what the gasket wants to bite in.
Nope.
And then when you create the ocean on top of the block or in the head, the gasket just hates life. So use a super scraper with a carbide tip, and it comes off really fast, really clean. They've got them in 3 different thicknesses that I'm aware of, or at least I own 3 different thicknesses. They work really, really, really good, and you don't screw up all your surfaces. So rule 1 about head gasket changes. You hit the nail on the head with, you got to measure piston protrusion. Yep. So basically when the piston's at full top dead center, you measure the piston in 4 different spots, and they're all going to be different because the piston's kind of cocked in there, right? You would add up those 4 numbers, divide those by 4. That would give you an average piston protrusion. And with 12 valves, the tighter the compression, the better they run on the street. So, you know, like 25 thousandths protrusion is really good.
Yeah.
If you have to deck the block, measure your protrusion before you do that, and then deck the pistons equal and put the pistons back in their respective hole.
Yep.
Make sure they also stay with that connecting rod, because connecting rods are not the exact same either. So you really want to make sure you do your measurements and put everything back together exactly as so.
Number everything.
Everything. Pistons, connecting rods, all of it. Just use a little engraver and put one on the rod, put one on the piston. So if you've got to deck your block, then there you go. Like, you do that, and that will give you, if you've got to deck that block 6/7 thousandths, measure your protrusion. If you were at 22, then you basically had 3 thousandths more to grow before you start running into like valve issues. So go ahead and deck the block down like 10, so you've got a really nice clean block, and subtract off the pistons, whatever you need to keep that 25 thou as your goal. So yeah, if you're doing a 10 thou thicker head gasket and you buy a set of injectors at the same time and you call me and you complain that they're smoky and they're nasty, that's because you've pulled the nozzle out of the piston bowl and it's starting to get above the bowl and it's going to haze for the rest of its life. Enjoy. You've done that, not me. I just warned you though, don't do it. Back in the old day when I was a kid, we used to think that going lower on compression was a good thing for horsepower, and it was going to make us, it was going to make everything better, but it really made everything worse. So when you're making huge cylinder pressure with huge turbos and all the things, and you've got poor quality fasteners, lowering the cylinder pressure or the compression ratio can help you keep the motor alive a little bit longer. But we now have ARP fasteners. We don't need to get rid of all the compression to try and maintain the motor's integrity. So it's just a way better deal if you keep the compression as high as possible.
If somebody puts a 10/20 over gasket, can we fix a set of injectors for them?
Theoretically, what you could do is you could take the nozzle nut off of the injector and machine the nozzle nut down like in a lathe and get the nozzle protrusion back in there. But you're still losing 10 thou is about 3/10 of 1 point in compression ratio.
There you go.
So it's not, you're never going to gain back that compression. You've lost it.
Right.
And when you give up that compression, you give up fuel economy, throttle response, power coming under the curve, so coming off a stoplight, things like that.
Yep.
All those things are gone forever. So the only way to fix that, if you're going to use that gasket, would be to cut the block. And at this point, it's probably not a bad idea anyway. Them blocks are all pretty old.
Yeah, even if you start with a 98, that's a long time ago.
So back in the old day when people started using O-rings, it was like we were using the O-ring material before ARP came out with a fastener for a 12 valve. And what we ended up doing was putting way too much, it was like 040 piano wire, like a stainless steel piano wire.
Holy cow.
And it's thick wire, like it's plenty beefy. And we would, reading the instructions, we left about 18 thousandths of the wire proud. So we barely got it in there halfway.
Yep.
And what I discovered is we would put so much clamp load in the fire ring of the piston, but nothing was clamping down on the composite portion of the gasket.
Okay.
So the oil and the coolant jackets weren't really being sealed up. So went to the machine shop, I was scratching my head, I'm looking at this, and the machinist's like, well, I see it right there. I'm like, what do you mean? So we grabbed a caliper, and we started measuring the gasket, and the gasket is supposed to crush by about 4 thousandths of 1 inch the entire surface across, and I wasn't crushing the gasket at all.
Okay.
So we basically, very carefully, because that's a stainless wire, and getting back into those same grooves again would have been very difficult. So we chucked up the cylinder head and we started machining the wire surface down with fear of pulling the wire out and then having to redo a groove, right? We were able to pull it off. So we basically cut the wire using the surfacer, and we got it knocked down to about 8 thousandths of an inch, put it together, ran it, and it was better than it was. But it still blew a head gasket, and this is like 650, 700 horsepower. Still blew a head gasket, brought it back in the machine shop, measured the gasket, and we were crushing it just a touch, like barely like a thou did we get any crush out of it. So my machinist at the time, his name was Rob Estes, super smart guy. And he's like, look, in the gas world, like, I don't know shit about your diesel stuff. But in the gas world, we machine that down to, or we leave the wire proud by about 4 thou. And I'm thinking, if it's 4 thou, like, why bother? But it is
right.
4 thou, like it's there.
It's a little bit.
So we knocked it down to about 4 thou and started running it, and everything was pretty good. We actually got the gasket to crush, everything worked. So if you're gonna do O-ringing, you wanna make sure that, in my opinion, you leave about 4 thou wire proud, and you'll get good clamp load on the gasket, and you'll still have a bit more friction or a bit more traction on that firing of the original gasket. So that's my advice for that.
What's the common stuff we use now? 035.
Wire?
Yes. Wire
I think it's still 040 wire, but we just, now with that tool, we make sure that we do the math and leave that wire only about 4 thou proud.
Okay. I got a head on the race truck that's O-ringed. I'm pretty sure it's 035.
Is it? I could be wrong too. That's 20 years ago. I thought it was 040.
I'm pretty sure the new stuff's 035.
No, if it is, then that's fine. Wire diameter doesn't really matter.
No.
Whether it's 030 or 040 or whatever.
The protrusion,
as long as the protrusion is like 4 thou. So, head studs, like, we always use ARP around here, and I've had very little problems with that. But back in the old day, when we first started using head studs, we would put the head stud all the way in, and of course we would use, like, some sort of a little, like, 1/4-inch drive pneumatic.
Oh yeah.
And just bzz, 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 and we broke a few of those studs. Meaning we would install them, we would put them in using the little impact gun, the little 1/4-inch drive ratchet, so they weren't tight to the block, but they were in the block.
Yeah. Right.
And then when we would go to pulling on the head studs, they would crack and pop and do weird things. And once in a while, probably 3 times, we had studs actually break when they were in service. So the vehicle would come back, we would go to break all the stud nuts free, and one of them was just free. It was just in there rattling around.
Yep.
So discovered that you're not supposed to do that. You're supposed to put the head studs all the way in the block and then pull them out. I like 360 degrees, so 1 full revolution. That way there's a gap between the block and the stud. And now when you're starting to pull on the nut, if that stud moves, it's not going to move a full rotation and bottom itself out.
Yep.
So you're pulling on the stud, trying to stretch it, not trying to jam it in the block and then try to stretch it.
Exactly. And the instructions do tell you to do that.
The instructions back in the old day were horrible.
Yeah, the new instructions tell you.
Yeah, they've got 20 some odd years of guys like me calling, going, hey, I tried this and that didn't work, and I tried this and it fixed. So yeah, I've not read an instruction in a long time. What else? Gasket thicknesses, nozzle protrusion, head stud torque. We pull the black ones to, what do you pull them, like 150, 140?
140. Yeah, we pull them to 140.
And then if you're going to use 625s, they are stronger, they're a better material, and you can pull on them tighter. But back in the old day, I did discover that when you use a 625, we would pull those things like 160, 165, and basically it put so much stress on the block that it would taper the top of the bore and it would open up the bottom of the bore. So when the piston goes down to the very bottom, it had like an extra thou and a half clearance because it was literally trying to stretch the block around the studs.
Wow.
And then it would close the top of the bore by about a thou and a half. So my advice is, if you're going to use 625s, you use an actual torque plate, you bore your motor, and you do your final hone with the torque plate installed and the exact same set of studs that you're going to build the motor with. So you've already pre-stressed the block, and then when you take the torque plate off, you put everything together and it's basically deformed. But when you reassemble it, put your cylinder head on it, torque it correctly, at that point it pulls the block straight and true, and your bores will be straight again.
Yep, that's the whole point of the torque plate.
Yep.
Literally what it's for. So any good machine shop uses a torque plate for machining.
And if they don't, well, they're not that good.
Find a new one.
Yeah, if you're making power, like stock power, you can get away with a lot of stuff. But when you're starting to make bigger power, you really need to make sure that you create recipes and specs that work for your power level. So it's just a trick. Nozzle protrusion, torque plate, timing. Okay, let's go back to timing.
Yeah, timing.
The shorter, the more violent you can get the fuel in there, the less requirement there is for timing. But again, if you're going to inject more quantity, it takes more time for more quantity to burn, so you're going to have to add some timing.
Yeah.
But if you do, let's say you were going to do 100 horsepower additional with a stock injection pump, stock injectors, just by moving a fuel plate around or possibly removing the fuel plate, you've now you basically doubled your injector on time.
Yeah.
And because of that, you're going to have to add a lot more degrees of crankshaft revolution timing to get that in there by the right burn rate. And besides that, piston goes up. If you start injecting fuel at, say, 16 degrees before top dead center, but you're injecting fuel for, say, 40 degrees crankshaft revolution, the piston has run away. As you're still injecting, your pump's still hammering that injector, and you're still chasing that piston down the bore as it's losing compression. Because of that, it's always going to be hot and smoky because you're not burning all the fluid that you're trying to put down its neck. So, not good. Let's say you're going to do 100 horsepower with like a delivery valve and a small injector. You can do that with a stock fuel plate, possibly even the exact same location.
Oh yeah.
And the delivery valve is going to hit the injector line harder. That's good. That's like making rail pressure on a common rail. Mm-hmm. And the higher flowing injector is going to get more fluid in there in a shorter duration of time. So you won't need to advance the timing near as much. You're still, I would say any respectable 350 horsepower truck should be 15, 16 degrees of timing.
I'd say 16 for sure.
But if you try and make 100 horsepower just fuel plate, like it's going to take a lot more timing than that to get it on time. So, one of my least favorite questions is hole size. Like 12 valve guys, the reason that 12 valve guys talk in hole size is because in sled puller days, way back in the old, it was we would drill out these VCOs or EDM these VCOs to 5 by 20, 5 by 18, 5 by 30, and then the guys that are selling a bunch of Chinese parts basically don't have any way to measure anything else other than hole size.
Yep.
So in a minute, we're going to go downstairs and I'm going to show you guys what it's like to really, really, really measure a hole, not just using a pin gauge. We use pin gauges around here for other things, but it's not to get an accurate measurement in a hole diameter. I would rather measure them in flow, and flow doesn't necessarily mean everything either, but because if I give you, let's say we take a P570 nozzle, which a lot of people are running right now, and we extrude hone those from 50, those things come in at about 51 to 54 liters of air per minute. If we advance that to say 56, some of them are barely moved up, some of them are moved up by quite a bit, but that's a nice clean hole. Now if I take the exact same nozzle and I shove a bunch more extrude hone media through it, my length over diameter of the hole orifice starts to go away, meaning my hole starts to look like a great big bored out like ice cream cone. And if you picture that orifice being a rifle's barrel trying to get to the pocket of the piston, when you blow that rifle's barrel shorter, you end up turning it into like a sawed-off shotgun. And you don't get the fuel into the pocket, so they just get real dirty and real smoky.
Yep. Broadcast.
Yeah. It's not going to where it needs to get. It just blows out as soon as it hits. Yeah, it's not good. So with a P570, all right, let's start with Ecos.
Yeah.
Ecos, at one point we were trying to make an inexpensive part, so we kind of called it the Eco for like economy, and it was going to be a slight improvement over a factory injector. That way guys didn't have to change timing if they didn't want to. Well, there's nothing cheap about the Eco anymore because with pilot hole technology cleaning up the 1s, 2s, 3s, and 4s so much, the Ecos were way dirtier than even a 4. So we ended up having to put pilots in the Ecos as well now. So you're getting, if you're buying an Eco, you're getting an extremely high value because it still comes with pilots, but they all are at 53 liters of air per minute, and a factory P477, 464 was like, I want to say it was about 37 liters of air per minute, 37 to 40. So it's a big improvement. It's like a 20% increase in volume, 25% in volume. But the spray orifice itself of a factory part was just EDM'd only, and that's not very efficient.
Yeah.
So, because we know that K factor makes a big difference.
Goes a long ways.
So we start with like a 10.5 thou wire to make our 5 primary holes on Eco, and it comes out to about 12 thou 5/10. And here in a minute, I'm going to walk downstairs. I'm going to show you that when I say 12 thou 5/10, that's like 12 and a half thou. You won't get a 12 and a half thou pin gauge in there, period. It will not fit. But when we use the Starrett and use a photo eye, that's what it measures at. And if I check the next hole, it may be 12 thou 4/10, 12 thou 6, but about 12 thou 5/10. So it's an extremely accurate way to measure things, and trying to get things that accurate with EDM man, there's a lot that goes into it. So Eco's 53 liters a minute, and they're about 12 and a half thou in wire diameter, hole diameter. Now, stage ones, which are kind of my favorite injector, 56 liters of air per minute, and they're about 12 thou 8/10. So not even a half thou difference, but we've gained from 53 up to 56 liters a minute. And on the dyno, we've done back-to-back testing.
Yeah.
What was your thoughts?
The stage one's great. I like the stage one. It is incredibly clean. And then when we started putting the pilots in, that's a new thing we started doing. And the pilot holes in the stage one have made that a very crisp, snappy, 400 horsepower capable injector.
Yeah, and that was, I mean, we've got a good pump in there now.
Yes. Well, that was even on the pump that was just
not great.
Not great. Yeah, not great.
Had a horrible camshaft.
Yeah.
Like for most of you guys that are driving 160, 175s, we had the same camshaft. And now you can honestly say that that cam starts to really throw its shoulders forward and kind of lunge over at about 400 horsepower.
425. That was the very last bit it would make, and it was dirty smoky trying to do it at 400 horsepower, perfectly clean. 425, rolling coal like a sled truck.
Yeah.
So it was done.
Not cool.
No.
So the stage twos go from 56 liters of air per minute. So we got 53 Ecos, 56 stage ones, and stage twos are 63. So it's a really big jump. And I would say that the Eco and the one are both safe for 160 and 175 pumps.
Oh, 100%. Yeah.
A 2 or bigger is not the right choice.
Yeah.
For that camshaft. You don't have enough injection rate. The ramp rate's not good. There's no fill time. You just don't have enough injection pump camshaft to really drive a stage 2 effectively. So I wouldn't really advise anybody doing that. But if you have a 180 or a 215 style camshaft, then a stage 2 is a really good choice. You have enough pump to drive it. The hole diameter is about 13 thousandths and 2/10. So what it is we take like factory P570 hole size, and we add pilots to that, and then we add K-factor using abrasive flow machining. The stage 3 recipe is the exact same wire size, but we AFM it for a few seconds longer, make it from 63 up to 67 liters of air per minute. And because of the extra AFM time, we add just a little bit, about 3/10 of 1 thou. So about 13 1/2 thousandths of an inch is a stage 3. Now, if you've got a 180 pump, I think we both agree that the 2 is kind of the spot, right?
I would say so. Yeah.
A 3 will work on a 180 pump, but if you get real carried away, and if you're gonna use a 3 with a 180 pump, you're gonna want a good violent. I've never tried a 7mm delivery valve.
I haven't either. Never been around one.
I assume that it's going to hit the line as hard or harder than an 024.
It should. It gets a little bit bigger, isn't it?
Yeah, it's supposed to be. You still want a retraction collar on your delivery valve, but we would use a 024 delivery valve with a stage 3.
Yeah.
Because we want to punch the line as fast as we can and keep the line pressure up as violent as we can. You can probably get away using a factory cam plate profile, so you can keep that injection event nice and tight and short. And timing, you're going to want a bit more timing with a 180 pump than you would with a 215 pump. So 3s being there at 67 liters of air per minute, the hole diameter is 13.5. At that point, a 215 pump with a good set of delivery valves is going to make a really ripper. you're going to get an easy 600 and
Oh yeah.
650, 700 horsepower out of a pretty mild tune-up, basically. Bear in mind that on a 215 style pump, you can get away with a little bit less degrees advanced timing. As it makes rack travel, it starts to give you timing. So that's nice with the 215 style plungers. And if you've ever been in a test stand or been around a test stand when you're running injection pumps, flat top plunger, when it's all run out, is going to pump about 450, 460 cc's delivered through like a .08 plate on the test stand, the nozzle. And with a 215 pump, when you run out to 20, 21 millimeters of rack, those things will pump 900 cc's of fluid. I'm not saying that you need to try and use all that, because to do that, you basically have to pull the fuel plate out, give it 21.5 millimeters of rack, and ultimately, the damn injection event never really shuts off. That's why you're getting so much fluid.
Exactly.
So, you know, these truck pullers with really hostile, violent camshafts, hostile, violent plungers, 13s, 14s, they're using 600 cc's to make 12, 1300 horsepower. You don't need 900 cc's, and it won't make more than 1200 horsepower anyway.
Yep.
If you're trying to build a dyno queen, because nitrous is awesome, you can leave the injector hung open that long and you can spray it clean and it will make a huge amount of power, because 900 cc's is 900 cc's if you can get it to burn. Nitrous will help you burn that. So you can make a pile. We had a customer make 1700 rear wheel horsepower on a 215 style pump and some like 80 or 85 liter a minute injectors probably 8 years ago.
Holy cow.
So it can make big, big power. If you set it up to be a dyno princess, it'll do it. Now, the stage 3 also, because when you stick a rack and it's hung wide open, it's a bad day. It scares the hell out of you, and it's really hard on engines if it doesn't shut off. So stage 3 is the very first step if you're going to run a 13 millimeter pump that you want. You don't want to run a stage 2. It's too small of a nozzle and the injection pressure is going to be too high, and you're going to stick a plunger on a stage 2 with a 13 mil pump. So heed the warnings, don't do that.
Yep.
Stage 3 is your street friendly nozzle for a 13 mil pump, and it will be wicked violent. It's going to be super crispy. Throttle response is going to be ultra sharp. You drive over railroad tracks, your butt cheeks move in the seat, and that thing's going to go from 0 to 200 horsepower every time your foot wiggles on the pedal.
Exactly.
It's pretty violent. That's 13.5 thou wire, 6-7 liters a minute, stage 3. Stage 4. It's kind of a big boy.
They're big.
Yeah.
Yeah, they don't mess around.
73 liters of air per minute, and the wire diameter, or the hole diameter, is just shy of 16 thousandths. For all of you guys out there that are like writing on these forums saying, I've got some 5x18s and I want to know how to clean up the smoke, I just told you, you can't.
Yep.
By the time you get that thing cut down to try and, basically what's happening is your nozzle is so big and it's so effective at evacuating out the injection line. There's no injection pressure, so they're constantly going to be hazy and smoky and gross. Throttle response isn't going to be that awesome. That's why. It's just too big of a nozzle. So with a stage 4, that's a hell of a lot of injector nozzle. 15 thou 8/10ths. And from 4s on up, everything is custom.
Yeah.
So we make these guys fill out these custom injector order forms based off our website, and we look at the entire setup and then call and advise on what we should do for custom angles, custom hole sizes, what we're going to do for bodies. Once you get above 80 liters of air per minute, we need to do body modifications. We have the dual feed bodies.
Yeah.
We have 1.5 millimeter cross section of sack value, so we can actually do clear up to like a 5 by, I think I put a 5 by 35 hole.
I think so. I think that's what it was.
It was huge. It was ginormous.
Monster.
Like that would be like 3,500 horsepower kind of thing. So we can go custom clear up to huge. They're not that expensive anymore. They're only $1,750 right now for dual feeds.
Yeah, that's a killer.
We're not selling them because nobody really needs them. But 80 liters a minute is pretty much the end of the day. That's when you have to go with a bigger body.
And the stage 4s still come pilot hole.
Yes,
So-
yes. All of the street version of our injectors.
Yep.
My biggest fear is a smoky 12 valve on the street. So we put pilots in everything now. Ecos on up to 4s.
Yep. And they are worth it. The pilots make such a clean burning injector that it's great. Like,
When we released the pilot video, it was wild how many people came at me and were like, hey man, I've got a set of these sitting here. We bought them like 2 years ago. Is there anything we can do with these? I'm like, absolutely. Send them in, we'll add pilots.
Yeah.
So we did send Tom, buddy down in Oregon. My dog just got here, you guys, sorry. My buddy Tom down in Oregon, he sent in, I think, 1 or 2 sets he was going to do because they were sitting around there.
Yeah.
I think it was his and an employee's truck. And Liberty, come here. Come here. You guys want to see this? This little meatball? Libby, come here. Come here. Come on. There we go. What a meatball. What a meatball. You want to love on Mitch?
Yeah, we did.
Yeah. Okay, get out. Come on, let's get out. Oh, last night she was in the bed sleeping on the pillows.
And she's what, like just over a year old?
She's about 15, 16 months right now.
Yeah,
And she's
like 100 pounds.
it's like a battery.
Huge.
So at any rate, the what else?
Let's see, pilot holes. Okay, before I started working here, I'd watch videos on K-factor. Always, there's like never an explanation on what K-factor is. The best way I could describe it is if you imagine like inside the nozzle, you punch it through with the EDM, it leaves a dirty, just a square hole. With the K-factor, I like to describe it is it goes in and it makes that entrance to that hole like a velocity stack.
Yep.
Smooths it out and allows the fuel to flow into that smooth, and it cuts down your turbulence. Does that sound about right?
It does. And abrasive flow machining is way more technically challenging than extrude honing. Extrude hone is a silly putty-like substance, green screen now, boom. And then green screen now, AFM. So with AFM last week, Skylar, we built some nozzles that Skylar was running in the common rail test stand.
Yeah.
And he was getting pretty frustrated because he couldn't balance them. And then there's shims inside that allow needle travel to limit. He was frustrated because they weren't reacting the way they were supposed to react. So I walked over and I looked, and sure enough, he'd moved the shim by 2 or 3, which should be like a 12 mm jump or a 12 mm drop, one way or the other. And it was sometimes 3 and it was sometimes 20. My brain went into like, okay, well, what could cause that? And basically the hole that we were making was the correct wire diameter, but the AFM pressure was not correct.
Okay.
So we had it running for about 15 to 20 seconds of AFM time is what it was taking. And we were pumping about 1,300 cc's of AFM media through there to get our K-factor where they were.
Yeah.
So as an experiment, I cranked up the pressure by 50 psi. I decreased, to get the overall size that I wanted, decreased my time by like 5 seconds. And I looked inside the nozzle, and the K-factor was sharper, tighter, cleaner.
Okay.
And I was like, all right, try this one. And he put it in the stand, and it was more predictable.
There you go.
So I cranked up the pressure by another 100, and I decreased the runtime. I was down to like 500 to 600 cc's of media.
Oh, wow.
And the hole was really tight, and we ended up, this is things that kind of dynamically moved based on media condition, the AFM temperature. It only has a few degrees where it's got a chiller and a heater.
Yeah.
So it tries to keep the media at certain degrees. But man, it's sensitive. Like
Well, in an AFM, the media is more, I don't know, latex paint.
It is hydraulic tractor oil with
Okay.
a cutting agent suspended in it. So when we're standing at the AFM, you hear this ka-chunk, 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 and it basically has this like almost like a KitchenAid mixer, only it's big.
Okay.
And it mixes that stuff up all day long, so it never lets the agent settle. Back in the OG days, it used to be this diamond dust that they would cut into like 3 microns.
Yeah.
And the diamond was really hard and it was very expensive. And this stuff is $2,500 a bucket, so we don't abuse it, but it still changes characteristics. That bore scope that we have out there is critical.
Yes.
So we're always using, when things aren't working right, we're always, that K-factor, fluid dynamics K-factor is the inlet to any sort of spray orifice. If you picture a really rough EDM, boom, K-factor, none. This is a gross hole, super fast EDM, probably using oil, not water. That is something that we don't really ever practice here, ever. That would be something that I paid for a long time ago. And this is a picture of EDM here only. And that is a picture of the same hole with some abrasive flow machining run through it.
Yeah.
Now you can see what K-factor really is.
Yep, exactly.
Now, what makes power?
Fuel and air.
Fuel and air.
Yep.
Okay, I've got a question. If we go to the diesel pump or the gasoline pump and we fill up the gas tank, as long as that fluid is not burning, does it make power?
No.
Oh.
If it's not burning, it's not making power.
On the nose.
So if
it's so smart.
So smart. Black smoke ain't power.
No. You're basically, in truck pull world, the black smoke has to be there in some applications because they're limited on turbocharger inducer and air. Because of that, they've got to quench the flame down a little bit by overdoing the AFR to try and pull the EGT back out of it. But on the street, you don't have a limitation on air. You can use whatever turbo you want and just size it correctly for the horsepower that you want.
Yep. Look at the current drag racers. They're not smoky.
No.
Your current drag racers that are actually the front runners in the industry, you couldn't tell if that was a gas engine or a diesel. You'll never know because they're so clean.
Back in the old day, one of the OG bad mofos at the track was a little green truck, Stucky Racing. 3 dudes. They were awesome, loved them. Robert's still in business to this day, but back then he worked at Shiver Diesel, and they were sponsored heavily by Borg Warner, and they would bring turbos to the track. These are Borg, it wasn't SXE stuff because it was early that, but it was just box Borgs, and they were killing those things 2-3 a day sometimes because they were overspinning the ever-loving heck out of the turbocharger, and you can overspin a Borg or a whole set by a long ways, and they don't blow up. But you spin a Borg or a whole set too far and it blows up violently. They were killing them because back in the old day, we had no retraction collars on the delivery valves. It was full cuts.
Yep.
So injection event was God knows how long. We were taking P570 nozzles, shoving a bunch of media through them, and I was honing those things up to 73 and even 80 liters of air per minute, and they would haul ass. They would get the thing, it was like a low 10-second truck back in the day. But today, we could build a low 10-second truck without blowing up a turbocharger.
Yeah, for sure.
We would wastegate it. We would keep the injection event correct. Things were a lot different back then. You don't need to build your truck based off of 20-year-old technology or 10-year-old technology.
Exactly.
You can now redo your 10-year-old recipe and enjoy your truck way more, immensely more, because technology is a lot better today. We're also smarter, and we just know what didn't work and what does work. Common Rail, as funny as it sounds, has taught my brain how to vision what the injection pump is doing much better.
I mean, it makes sense.
When you're working with a guy on a laptop and you're talking, what are we going to do? Well, they have the ability to crank up pressure. Yep. We do, but it's only using delivery valves. And basically, if you increase the nozzle opening pressure, you put more hydro load on the plunger, and it makes the plunger hotter. And you also decrease the amount of volume that the nozzle is going to give.
Right.
So if it takes fuel and air to make power, by decreasing fuel, you're actually decreasing the potential of the horsepower, right? Yeah. We use 290 bar with VP44 injectors. They don't blow up. VP44s that chronically blew up before, set them at 290. I've been doing this since the year 2002, and VP44s quit blowing up. You set nozzle opening pressure on a P pump at 270 bar, size the nozzle correctly for the plunger that you're using, you won't have any plunger issues, and it'll give you very good service life, tons of mileage on both the injectors and the pump. With the little VE stuff, softer yet, 240, 245 bar.
Yep.
Lower opening pressure. Those things have more injector spray flow because the potential out of the pump is worse then, right?
Right, for sure.
So we have to make it more violent. We've got to, the injector just has to be bigger to keep a VE to keep up with a P pump.
Yep.
We don't need to get into that today.
No.
But
no.
I think we should get off these chairs.
I agree.
And we should probably go downstairs, show these guys what it's like to measure a hole accurately.
Yeah.
And maybe run a nozzle. Let's go do that. Let's go on a field trip, guys. Want to go?
Field trip.
Let's go on a field trip. You know where that big son of a bitch is? Let's find it. Everybody likes big shit.
Don't. Everybody wants to
Brian.
see big shit.
The dual feed big sack, I think it was like 5x35. Do you know where that nozzle's at, that hole?
Papa Brian's got his stash.
I come over here and make stupid shit. And then I leave it here. And then Brian has to remember what I made and where it's at.
32 wire.
32 is fine. That's going to be a 35 hole.
That's exactly right.
Oh, yeah!
Yeah. Get it.
08 wire. 028, 024. Just for giggles, let's grab a stage 1 and a stage 4 just so we can see a big difference.
I don't have any stage 1s, but I can grab the 4. We're out.
Well, I'm talking about nozzles.
I don't have any.
No, you don't.
I don't have any 4s
Well, I got
either.
I got a 2.
I got 2s
and
and 3s.
I just measured a 4 a minute ago. They're right here. 2 and a 4.
Okay. Are they actually are they AFM'd?
I don't think they are.
They shouldn't be.
Grab an Eco. They're the same. 3 LPM difference.
I got them right here. Okay, so that's just really nice, really clean EDM work. So we've got our 5 primaries, and they're in there on an elliptical angle because the injector sits on the exhaust side of the motor. And then we've got our 2 little pilots that are even closer to the piston yet. So path least resistance comes in and the pilots don't do anything. But when you're idling and just driving around at normal throttle settings, those pilots really help get things lit up. So that is EDM only. This is EDM only, no pilots yet, much bigger holes. So as you can see, there's kind of a ridge of metal right here, and those ridges of metal are going to impede the way that flows. So because of that, we would AFM this next. What you got?
Stage 3.
Stage 3. So this one's already done.
Yep, this is a production ready nozzle. Well, it's not sprayed out.
We'll get the WD-40 out of it. Okay, so so beautiful.
All the goodness.
Okay, so if you take a look at that transition area that is right here, all that's going to do is help increase the pressure in the spray orifice, giving you the most amount of atomization and the most fuel burned possible. So just for giggles, let's walk this over to the bore scope. Let's take a look. We'll measure the hole size and we'll see how round the hole is.
Yeah.
And okay, so I'll let you have that one. And here is my, okay, little one. Okay.
So you do a raw, and then we'll do the
Yep.
production model.
Okay, so there's a decent little picture of our pilot hole. And so let's go right here. Bring this down a bit. I'm going to check the pilot hole for size. And if you notice how round those little red dots are, this is going to be a nice round hole. So we have 0060, so 6 thou is what that hole measures. And it's tenths, hundredths, thousandths. It's 200 thousandths out of round. So basically it's as round as you can make a hole. Now, right here in this view, you can see that there's a little bit of flashing still around those bigger holes. And bear in mind, this one is not ready for sale yet. This is actually needing to be AFM still. So I'm gonna back up, we'll delete my last mark. We'll go to this again, we'll measure this. This hole is 13 thou 7 tenths, and it's 5 tenths, hundredths, thousandths, 5/10,000ths of an inch out of round. So it's a very, very round hole, ultra nice quality, because the guy next to me, Brian, is so good on the EDM. I lied, but it's okay. Now you can see that the AFM starts to change the hole roundness a little bit. Because when it goes through there, it's kind of like water that's abrasive, right? And the wire makes it extremely sharp. Getting K-factor in there, you have to run a little bit of AFM. Let's go here, let's go here. This hole, 13 thou 8 tenths, and again 0.0005 out of round. So super round. There's also no flashing on the outside of that anymore. It's nice and clean. Atomization is going to be amazing. So this is back to you, sir.
Yep.
Now I've got 032. Okay. This is just to show you guys we can do it. If anybody needs huge stuff, this is huge stuff. When I talk about section, you can see that the tip itself okay, so the tip itself is much fatter on the left than it is on the right. That's 1 millimeter, that's 1.5 millimeters. Why do we need this? Because it's a larger area with more surface area, and we can evacuate more fluid and put a much larger hole in it. Okay, so there's the little guy back. Now this,
Good Lord.
just kind of an overlay. That hole's basically quadruple what the other one was, and you can see damn near clean through this nozzle. Okay, so this looks goofy because that shadowing right there is actually the inside bore of the spray orifice. But let's measure it and see what we got for hole size here.
You might have to switch that over to kilometers.
Kilometers. It doesn't like it because it's so big.
It's,
Done. 0.35.5, so just shy of 36 thousandths of an inch. And it's 0.0021 out of round. So again, ultra high quality stuff. Now, when we refer to dual feeds and single feeds, alignment dowel, alignment dowel, alignment dowel, alignment dowel, alignment dowel, feed port, dual feed ports. So we've got twice as many feed ports, and these are parts that are made at a factory for us. So these have not been drilled or EDM'd in-house. This is something that I actually blueprinted, had built, and shipped into us. We just put all the spray orifices and do all the AFM in-house. So feed port, dual feed port, that's what we're talking about when we say dual feeds. Now that being said, Brian.
Yep.
Can I use your flow meter real quick?
Absolutely.
Actually, you know what, guys?
You gotta use the one
Let's
next
walk around the corner. Okay, so 0 to 100 liters of air per minute flow meter. This is our standard. Derrick Rose has a nozzle making, you know, around 3,000 horsepower that is 99 liters of air per minute. This does not run on the same injection pressure as Derrick Rose common rail, but still, you can see the ball just goes straight to the top. So unfortunately, this flow meter is far too small for this 5x35. But I've got this one right here. This one has a larger and a heavier ball inside of it. This one starts where the other one stops. So this thing is 195 liters of air per minute. That is a huge nozzle. So for mechanical guys, big P-pump stuff, if you're wanting to make that 3,000 horsepower mark, we can make you a nozzle, dual feed, 5x35. We never did look inside this though.
No.
Let's take a gander.
Yeah.
This 35, almost 36 thou hole maxed out this sack. I would need to, if I was gonna make these for a customer, I would move this hole over a little bit to give myself more distance right here. This is barely okay. This is good. This is exceptional, so I can move that hole down and make something for a customer pretty easily. This has not been AFM. This is just EDM'd only basically. And there we go. I think that was a pretty educational video.
I think that's good, yeah. Oh.
You guys, I hope this helps. Hope you get something out of it.
For sure.
We should probably get back to work and let the rest of the guys turn on all their machines again.
Yeah.
So, peace out.
See you later.
See you for Christmas. Remember, I like size whiskey.
I mean, if you're getting him one, I'll take one.